Okay, we started graphing these rational functions last Tuesday, and I'm going to do a quick review. Here's example 1. What you're going to do, we did this on Tuesday, your critical values are wherever you have a variable in the numerator or denominator, you're going to factor your rational function completely and set each equal to 0. So in this problem, you have an x in the numerator, so set that equal to 0, which obviously is 0. And in the denominator, x squared minus 3x minus 4, you're going to factor this completely. So this factors to be x minus 4 times x plus 1. So the factors would be 4 and negative 1. So the critical values for this problem would be 0, 4, and negative 1. What we do is we create an exclusion chart with these 3 critical values. So what I do, I make a number line. I organize these 3 critical values, and sometimes there's more than 3, sometimes there's only 1 critical value. But I organize them in order from least to greatest. So negative 1, 0, and 4. They have to be ordered correctly. Otherwise, this is going to mess up your graph. So negative 1 comes first, then 0, then 4. Be sure to leave room to the left and to the right of these numbers because you're going to make a table. Okay? Now, in your exclusion chart, you're going to place the factors of this rational function. So x, x minus 4, and x plus 1. And then the grand finale is going to be f of x. What you're going to do, this is my little trick, is you're going to find the number that gives you a 0 for each individual factor. So for here, I put if you set x equal to 0, you get a 0 right here. So to the left of this, you'd have all negative numbers, and to the right would be obviously positive. So in other words, if I were to pick a number to the left of 0 on a number line like negative 0.5, any number between 0 and negative 1, your number is going to be a negative. Any number between negative 1 and negative infinity, it's going to be negative. So any number between 0 and 4, like 2, it's going to be positive. To do x minus 4, pick a number in this region and subtract 4, it's going to be negative. So my trick is set this equal to 0, you get 4, so 4 is your 0. To the left is going to be all negatives, to the right is going to be positive. And x plus 1, set that equal to 0, so negative 1 is your 0, to the left is going to be negative, to the right is going to be positive. Then what I do is I count these negatives. I have 3 negative numbers, so my graph will be in the negative region. An odd number of negatives means your graph is going to be below the x-axis. An even number of negatives, so here I have 2 negative numbers, so it's going to be positive. This one has 1 negative number, so it's going to be negative. And this has no negative, so positive. So my graph, when I'm ready to draw the graph, sketch it without using a calculator, it's going to be to the left of negative 1 is going to be negative. Then between negative 1 and 0, it's going to be positive. 0 and 4, it's going to be negative. And then 4 to infinity, positive. That's what it's going to look like. But hold on to that for a second. Let's fill in this. The roots. The roots are your x-intercepts. This is where what you do is you set your numerator equal to 0. So you set x equal to 0, and that's where you will have anywhere your graph will hit the x-axis. So in this case, you're going to have an x-intercept at 0. Your VA stands for vertical asymptotes. This is where the graph will not cross the x-axis. These are your vertical asymptotes. You cannot cross, your graph will not cross at x equals 4 or negative 1. I want you to write these as lines. X equals 4 and x equals is negative 1. So right here, and you're going to make broken lines. Why do you not write these as solid lines? Because we want to distinguish between what is part of the graph and what is not part of the graph. So I create these broken lines as a contrast to what is part of the graph. Okay, now this is, we want to look at, is there a horizontal asymptote, a slant asymptote, or a parabolic? A horizontal asymptote is if the bottom has a degree that's more than the top. If it's bottom heavy, there's we have a horizontal asymptote. And this is bigger than that top. So we have a horizontal asymptote y equals 0. If it's top heavy by 1, we have a slant asymptote. If it's top heavy by 2, we have a parabolic. It can't be bottom heavy and top heavy. It's one of these three. Now, if the degrees are the same, we have a horizontal asymptote that is y equal the degree of the top, the leading coefficient of the top over the leading coefficient of the bottom. But that's not this case. These degrees are not the same. It's bottom heavy, so it's y equals 0. Now, the y-intercept, if you were to plug a 0 in the top and the bottom for x, you get 0, 0. A hole is where everything crosses, if you cross something out and you're not crossing anything out. So, now, to put this together, what you're going to do is look at between negative infinity and negative 1. Here's negative 1. This is a critical value, negative 1. And in this particular case, negative 1 is a vertical asymptote. You are negative. So you're going to draw this shape because you're negative. You want to stay within the asymptotes whenever possible. Now, a horizontal asymptote is a weak asymptote, whereas a vertical asymptote is a strong asymptote. You can cross a horizontal asymptote, and you will right here. Even though there's a horizontal asymptote, you do have to cross it here because you have to pick up that point. So between negative 1 and 0, you are positive, but we do have to pick up that 0, 0, because you have to go negative now, so you have to pick that up. You're going to follow that asymptote and then come down here, and then you're positive. So from here to here, you're going to make a positive shape graph. For number 2, what we did, we factored x minus 2x plus 1. Our critical values were 2, negative 1, and 1. We made an exclusion chart. Our factors, we came up with negative, positive, negative, positive. We came up with roots of 2 and negative 1. A vertical asymptote of x equals 1 because we have x minus 1 in the denominator. So we graphed x equals 1. We also figured out that this has a slant asymptote. Why? Because it's top heavy by 1 degree. How do you find a slant asymptote? You have to do either synthetic or long division. In this case, we could do synthetic. We divide. We're going to put a 1 outside the box, and then 1, negative 2 out on top. Bring down the 1. 1 times 1 is 1. Add 1 times 0 is 0. We don't need the remainder. So you're going to graph the line y equals 1x plus 0. Y equals 1x plus 0 is this line. Y equals 1x plus 0 is that line. Make sure it's broken. For this, we have a y-intercept of 0, 2. If you plug 0 in, here you get 0 over negative 2 over negative 1, which is 0, 2. And there's no hole. So putting this all together, your asymptotes, this is your graph, and we're done. The next one, we did not do this one yet, so we're going to start right here. Number 3. How would we want to first factor completely the numerator and the denominator. How do you factor x to the 4th minus 1? Well, it's the difference of two perfect squares. So it's x squared minus 1, x squared plus 1. Now we want to find all real solutions. So x squared plus 1 is imaginary. We don't need to factor that anymore. But x squared plus 1, we can get two real solutions, 1 and negative 1. So we can factor this to be x minus 1, x plus 1. So when we do our exclusion chart for this one, we have negative 1, we have 0, and we have 1. Now on going down, what are all of our factors? We have x minus 1, we have x plus 1, we have x squared plus 1, and we have a couple of x's. So we have x minus 1, we have x plus 1, we have x squared plus 1, and now the x's, you can do them individually or you can put them together, x squared. Doesn't matter. Huh? We have x minus 1, x plus 1, x squared plus 1, and x and x. X minus 1, x plus 1, x squared plus 1, and x in the bottom. Did you get them all? Did you get them all? Did everyone get them all? X minus 1, x plus 1. We have x squared plus 1, x and x. You want to account for all of your variables. Let's do this exclusion chart now. So x minus 1, let's find our 0. If you set this equal to 0, here is our 0 right here. So to the left, these will be 0, or negative, and this is going to be positive. At x plus 1, here's our 0, positive. Now this one's interesting. It doesn't matter what number you put in here. If you square a positive number or a negative number, what's going to happen to it? It's going to be positive. This was not necessary, but I wanted to do it anyway to show you. Now, is it going to be the case all the time? No. What if this factor, I'm going to just show you a sidebar here. Let's say this were x squared minus 10. Should I include it? Absolutely. Because if I put a number in and square it and subtract 10, it might come out negative. So be careful. Okay. What about this one? Well, at 0, it's going to be negative, and then positive, positive. And then count. 1, 2, 3, 4. 1, 2, 3. 1. And then positive. Did I do that right? So this is so far the first example that looks different. Why does this look different? Does anyone notice all of the other problems that we've done had a pattern? And in math we always look for patterns. The pattern that we've always seen has been alternating, plus, minus, plus, minus. This is the first one, so I would think, did we do something wrong? Plus, minus, minus, plus? So that would be my, I would be questioning, is this wrong? Okay, so keep that in mind. It's not wrong, because I know. but always think about your, you know, this one looks different than all the other ones. It's not, but always ask yourself, yes.
Is the third one minus?
Is the third one minus?
Like, why is the third one minus?
Because there's only one negative. You talking about this one right here?
Yeah.
There's one negative, so an odd number of negatives means negative. Okay? Yeah, you're used to seeing them alternating. So that, you know, when I first did this problem, I thought, wow, this is the first problem that it didn't alternate. So I thought, you know, could I be wrong? But it's not. All right, let's go through this before we start graphing it. What are the roots? Well, the roots are where the numerator is equal to 0. So we have a 1 and a negative 1. So what you're going to do is put a dot at 1 and negative 1. Our vertical asymptotes are where the denominator is equal to 0. So in our denominator is going to be x equals 0. So that's our y-axis. Now you're not going to be overly excited about this one because it has what kind of an asymptote? Our least favorite, parabolic, it's this one. So if it has this one, it does not have, it can't be bottom heavy and top heavy by 1. It has to be, this one's top heavy by 2. And how do you do top heavy by 2?
Long division.
You have to do long division here. I know you're so excited. But your favorite thing in the world to do. Now the good thing about this is we don't need the remainder. You can stop when you get the x squared. So this one's actually very easy. Huh? Oh, 0. Yeah, I forgot the 0. I put them in. I put the x squareds in. I forgot the 0. Yeah, they're all 0. They're 0. So really, all you need is to write x squared. And then you're going to get x to the 4th, and you're done. Because x squared times x squared is x to the 4th. And when you subtract, you get 0. You're done. Because the rest is remainder. So really, what is your parabolic asymptote here? It's y equals x to the 2nd power, which is this asymptote right here. Everyone should be able to graph this easy parabola over 1, up 1, over 2, up 1, 2, 3, 4. It's this easy. This is the easiest parabolic asymptote that you're ever going to be asked to graph, which is this. It's the easiest parabola you can graph. Is there a y-intercept in this? Nope. And is there a hole? No. Because x squared times x squared. Nope, you don't need the remainder. Okay, so now you've got a point here and a point here. How do you think you graph this? So let's put this together. From negative infinity to negative 1, which is our first critical value, we need to be in the positive region, but we've got this asymptote right here guiding us. So where's our graph going to be? I'm going to use pink. Pink's going to be our answer. We're going to be here, pick up our answer, our point, our x, our root, x-intercept. Then from -1 to 0, it says we're in the negative region. But we've got an asymptote, so we want to get close to that. You're there. Now from 0 to 1, we're in the negative region. And then from 1 to infinity, reminds me of a slingshot. Do you guys know what a slingshot is? That's it. This is one of the rare cases where it wasn't alternating, so we were right. Good? Okay, I want to skip to number 5. One of the more difficult ones. If you can do number 5. Okay, I want everyone right now to factor completely the numerator. What should you first do?
X.
And then what? And then what? Take out what?
X plus 5.
And then the bottom. How would you factor that? X minus 2, x plus 2, x minus 3, x plus 3. Okay, these are all your critical values. Can you please organize them for me? And let's fill out this exclusion chart. And I think you need to start right over here. You're going to put -5. For big mistakes.
Are you serious? I wanted to sound Bugs Bunny.
And I've seen this promise, I do this all the, I didn't make enough room. I made this chart, too long here and too, I have to go back and fix this. Okay, so. What you're gonna do is find your first zero right here, which is right here. So right here, you wanna make sure, what I did when I first put these here, and I see a lot of people make that mistake, which is fine. Just fix it. That's why it's good to use pencil. These are all negatives. You need a negative there. And if you had your variable x here, that's where you're gonna get confused. And then these are all positives. At 5, you got 5 here, so it's gonna be negative 5. Put a dot here. These are gonna be negative, these are positive. Negative 1, so you find 1. These are negatives. Positive, positive, positive. You guys know what I'm doing here? Negative 2. Positive 2, find negative 2. Negative 3, at negative 3, put a negative, negative, positive, positive. And then we count. You should count 1, 2, 3, 4, 5, 6, 7. 7 is negative, so that should be a big negative. And I'm going to use a different color. Let's use negative. 1, 2, 3, 4, 5, 6, so that should be positive. 1, 2, 3, 4, 5, negative. 1, 2, 3, 4. 1, 2, 3. And these all switch. You get that? Questions, anyone so far? Okay, tell me what the roots are. What does roots mean, first of all? It's where the graph hits where? The x-axis. In this case, it's 0, negative 5, and 1. 0, negative 5, and 1. At 0, at negative 5, 1, 2, 3, 4, at negative 5, and 1. I want to see a dot. You're going to get points on your test for that. Your vertical asymptotes, what does that mean? It's where it can't touch. Very good. At plus or minus 2, and x equals plus or minus 3. So on your graph, I would like you all to put a broken line at 2 and 3. 2 is the plus or minus 2 and plus or minus 3. Now, what does it have? A horizontal, a parabolic? What kind of asymptote does it have? Is it top heavy, bottom heavy? It's top heavy? Is it bottom heavy? Count the bottom degrees. I see 2 and 2 on the bottom. How many degrees are in the bottom? It's 4. 2 and 2 is? 4. It's 4, so it's bottom heavy. So this one has a horizontal asymptote that's y equals 0. So this one has a horizontal asymptote of y equals 0. Now, look at the middle, it has some points that it's got to cross. Remember, a horizontal asymptote is a weaker asymptote. which means it can cross, there's points that it could cross, which it's going to. A vertical asymptote is strong. It's not going to cross, but it could cross right here and it's going to. What is the y-intercept? It's 0, 0, and there are no holes. So let's do the graph here. So let's read this. From negative infinity to negative 5, we're in the negative region. So we're going to be over in this region. We're following this asymptote, and we're going to pick this point up. From negative 5 to negative 3, we've got to be in the positive region, so we're going to follow this asymptote up. Now from negative 3 to negative 2, it says we need to be in the negative region. But the negative region is this little skinny little area here. So we've got this asymptote. So how can we stay in this skinny little region? Well, if we drew a little, it's a skinny little parabola, that's how we could do it. This is one of the harder problems. Negative 3 to negative 2 would be a little parabola. Then how would you do from negative 2 to 0, and it's positive? You would do something from this asymptote, pick up that point, your y-intercept. Now we've got to go negative, slightly, because we've got to pick up this point right here. Slightly dip down in the negative region, pick up your 1, 0, go back up, and now we've got to do a negative region again. Do something like this again. And then we want to be from 3 to infinity. We're going to go another like that. That was one of the more difficult ones. Okay, take your homework. Let's do some of these together. Number 1, 23. Everywhere you see an x, you're going to have a critical value. I only see one variable in the denominator, and that would be 5 here, so it's x equals negative 5 is your critical value. So when you do your exclusion chart, it's going to be very simple. You're going to have negative 5 here. Oops, wrong way. Negative 5 here. So when you do your exclusion chart, it's going to be super simple. It's just negative and positive, right? There are no roots. You guys know that? There's no roots. There's no variable in the numerator. The vertical asymptote for this is going to be x equals negative 5. This is bottom heavy, so it has y equals 0 as a horizontal asymptote. It can't be top or top heavy by 1 or 2. And there are no y-intercepts, or I'm sorry, there is a y-intercept. 0, 1/5. 0, 1/5, and there are no holes. So what does this thing look like? Here's your y, 0, x equals negative 5. Here's your horizontal asymptote. Here's your y-intercept. And to the left of -5, you're in the negative region. And to the right of -5, it's going to look like this. What do you think about that? Easy? Okay. This is your homework. We're just working through them. Okay? 25. Take a second, start it. What do you think your critical, we have one critical value. I need to sharpen my pencil. This one has a little twist to it. What's your critical value? What's your critical value? Yeah, what is another name? What? Negative what?
Negative 2.
Yeah, negative 2.5. Negative 2.5 is your critical value. Okay, now I got a little. We have a problem in this problem. We need to include in our exclusion chart -3. Let's show you why. And why didn't we have to include 1 in this problem? Because 1 is a positive number. And the negative numbers are what, the negativity is what's going to change. The amount of negatives is what changes whether it's up above the x-axis or below. This negative, you have negatives here and here. This, if you're going to put a dot right here, and you're going to have negative here and positive here. Pretend like there's a 0x here. You're going to include this negative here. You're going to count. You have 2 negatives here, so that's positive. And then this is negative. Does that make sense? Because pretend like you have plus 0x. The number of negatives is going to change. You're counting the number of negatives in the problem. Here you didn't count it because you have plus 0x here. It's not going to change. You have a positive 1 here. It's not going to change. You have a positive number here. It's not going to change the, you're not going to get a negative anything out of a 1. But here you have a negative 3x plus 0. You have a negative 3 plus 0x. You've got a negative number here. It's going to keep this negative. So you have a negative here and a negative here. A negative times a negative is a positive. So it's going to make your graph positive in this region. It's going to be positive. So when you plug a number in to the left of negative 2.5, it's going to be positive. So when you make a T-chart, in other words, if you were to make a T-chart and use a number, this is basically what you're doing. When you plug a number in to the left, instead of making a T-chart, when you plug a number to the left of negative 2.5, your negative numbers here will cancel out, is what that's doing. So here, your roots, you don't have a variable in your numerator, so you're not going to have any roots. Your vertical asymptote is going to be x is equal to negative 2.5. So at negative 2.5, put a vertical line. you're not gonna have any roots, it's bottom heavy, so you're gonna have this, again, y equals 0 is gonna be your horizontal asymptote. You can't have, it can't be top heavy if it's bottom heavy. How about your y-intercept? If you plug 0 in for x, yep, -3/5, good job, and there are no holes. So, how are you going to put this together on the graph? To the left of -2.5, you're above the x-axis. Looks like that. And to the left of -2, oh, we got to put our y-intercept in -3.5, or -3/5. Right there, and then this is going to look like this. Good. 27. Give me the two, there's two critical values. 0 and 1. Is it time to go? Okay. Let's stop here. And do as many as you can this weekend, and we'll finish on Monday.